Hey, what's up, everybody? Chapter 3. Okay, it's a little bit longer, so bear with me on it, but it's a ton of information that it's going to come back throughout the year. Chapter 2 is categorical data, which we'll come back to a couple times, but really the bulk of statistics is analyzing quantitative data. So that's what we're going to look at today, kind of an introduction to it. The next couple of chapters are going to, also, or I guess the next chapter will also be quantitative data as well. So obviously we're looking at numbers now with quantitative data. And what we'll usually do is we'll summarize the data, try to look at individual data. It doesn't tell us a whole lot. And it can be obviously very time consuming. So first thing, as what we talked about in the last chapter, we want to make a picture. Okay. We don't use bar charts or pie charts now for quantitative data. It just doesn't make sense for that. We don't have categories. We don't have percentages of a whole and whatnot. So that's what we're going to talk about, kind of how the types of displays, and then how to analyze those displays. So in your textbook, which you don't have a paper copy of, but you have a digital version of it, there's an example on earthquake magnitudes over in history, basically, displaying the distribution of it. So basically what we can do is, if you look at the second bullet point here, we slice up all the values we have. So from the least magnitude to the highest magnitude. And we put them into equal width piles, which we call bins. Okay, so each bin will be like a certain magnitude, maybe like 1.0 to 1.5 or whatever. Okay, and then we basically look at how many fall into each bin and put that all together, and that gives us what's called our distribution of the quantitative variable. Okay, so if we look at that, this is an example of a histogram of the distribution of earthquake magnitudes. Okay, so the histogram plots the bin counts as the height of the bars. So if we look at the heights of all these bars here, that's the frequency. Okay, you can say there's 50 here. These were whatever 60. And if you look at the horizontal axis, that's the magnitude. So this looks like 4 to probably less than 4.2, and this would maybe be 4.2 to 4.4, and so on. Okay. So that's a histogram. You've probably seen them before. We'll be using the histograms quite a bit. I will say you'll rarely have to make one by hand. Okay. Usually we'll use either a calculator or we'll use our StatCrunch software to do that. Okay. Relative frequency histogram. Just like a relative frequency bar chart, everything is the same over here. The only difference is our vertical axis is now as a percentage. Okay, otherwise, no different. Okay, calculator will make a histogram for you. I'm going to kind of show you that here in a second. And so how to do it and then how to kind of adjust the bin widths and kind of experimenting with it. I'll show you kind of an easy way to where your calculator will pretty much always give you a good bin width. So in a graphing calculator, you can see my magic one here that I did not illegally download. So basically what we can do, and we'll practice this more, but this stat button right here is going to be very important throughout the year. Okay, most of these other ones you don't use a whole lot, but the stat button, right, and this has a variety of things. This first one, we're going to use the edit function here. It's basically a little spreadsheet in the calculator. You can see there's some other things. All right, these are some calculations that we'll look at later in the year. The tests, this is all second semester stuff. So what we want is, again, this is stat, and then we're going to go to edit. Okay, and then you can just enter data in. I just made up some numbers here that are kind of close to each other. I think I put like 15 numbers in or something along those lines. All right, if you have stuff in there, so let's just say got a list with something in it, you can either hit delete and delete them all, or if you scroll up and highlight the list and then hit clear and then enter, it'll delete the whole list for you. Okay. One piece of information that I'm sure you'll probably ask me all the time throughout the year. What happens if I accidentally delete a list? Okay, so let's say L2 is gone. All right, what do you do? All right, well, it's really easy actually. Just go to Stat, back to that original screen, and go to Setup Editor. All right, what this is going to do is just put everything back. So you could delete all your lists accidentally or whatever, and this will put them all back. So you just hit Enter, then hit Enter again until it's done. Okay. Again, that was Setup Editor. So then if you go back, L2's back, so you're good to go. Okay. So anyway, once I've got my data entered, again, I just made up some data here. Okay. What we want to do is we want to go to the stat plot. Okay, everything up at the top here is for graphing. We want the blue stat plot. So we want to hit second, y equals. Okay, and we want to make sure these are off. Okay, make sure 2 and 3, or if you have more, make sure they're off. We want to just go to number 1 here. Okay, you want to turn it on, hit enter on the on. And then you've got a variety of graphs here. This first one is a scatter plot. Okay, that'll come into play in our next unit, not for a few chapters. This line plot, I don't know that we've ever used it in AP Stats. Okay, right here's the histogram. You can see it looks like a histogram. Down here's a box plot, which we will also use quite often. And this is one that shows outliers. This one, don't ever use this one because it's a box plot that doesn't show outliers, so it's not very beneficial. Okay, and then this last one is called a normal probability plot. Nothing you need to worry about yet. We'll get to that later. So, histogram, let's make sure it's highlighted. And then basically this is where's it pulling the data from? Well, I have my data in L1. Okay, if you can look down here, there's L1, L2, L3, L4, L5, L6. Okay, so just second one will give you your L1. The frequency, just leave it as 1. It's not something we want to mess with. We'll use that a little bit later in the year, but don't just leave it as 1 right now. All right, so now once you've got the data in, and once you have the stat plot set up, all right, you want to hit everything, every time you graph in this class, every single time, you want to hit zoom and then 9. You can just hit the number 9. Okay, for zoom stat. That's going to give you a pretty good window for the data you're using. So zoom 9 every time. Okay, there's our histogram. If you go to trace, you can see, okay, so this bin goes from, the minimum is 9, and it goes up to less than 11. So anything basically that was 9 and 10, or if there were decimals up to 10.99999. Next bin goes from 11 to less than 13, and so on. Okay. Then we got a little gap there. I had one in that bin. Okay. So that's kind of a quick crash course on creating a histogram. If you wanted to create a box plot, which we're going to talk about, actually, we'll just hold off on that. We'll talk about that later. All right. So back here. Okay, stem and leaf displays. I'm sure you guys have seen these before. You've made them. It shows the distribution basically just like a histogram does, but it shows all the individual values. So that can be helpful sometimes. Doing these by hand is a pain. You'll have to do it a little bit. You need to be able to do it. The calculator does not do it, but the StatCrunch software that we have with your textbooks does do it. So I'll show you how to do that in there. So you can look here. This is the same data. This was pulse rates for 24 women at a health clinic. So if we look, here's our histogram. Here's our stem and leaf of the same data. Okay, so this means that's 88, 80, 80, 80, 80, 84, 84, 76, 76, 76, and so on. Okay. If you look, the shape of this is basically the same shape as that. Right, it's just kind of mirrored and flipped, I guess, if you think about it. Okay, here's that peak there, there's that same peak. All right, so shows basically the same thing, shows the shape, and also shows what all the individual values were. But obviously, if you have like 150, kind of hard to make a stem and leaf, so keep that in mind. All right, so making the stem and leaf, I'm going to briefly run through this. So basically, we just want to organize all of our data, figure out what our stems will be. Okay, in this case, numbers range from 56 to 88, so our stems will just be single digits. You can see it broken up by twos there. So like this was anything from 60 to 64. This was anything from 65 to 69, 70 to 74, and so on. Okay, basically, it's kind of up to you if you want to do that or not. If the data is all kind of tightly clustered together, usually a good idea to maybe spread it out a little bit. There's not really like a set, this is what you do when. You just kind of have to look at the numbers and make sure you don't have like, if you only have like, 5, 6, 7, and 8, might not show us a whole lot. So just things to keep in mind there. Sometimes you want to split them up there, right? Then it's splitting the stems. So 1 digit for each leaf. So every time there's a 74, you put a 4 for every time that happens. Make sure you always have a key so they know what they're looking at. As you can see, your textbook did not give you a key. But you always want to have a key, and it just would be you would put like 8, a line, and then 8 means 88. Okay. If you have over 100, you would just, like, say you had 90s and then 100s, you would just have a 10, and then whatever the ones digit would be after that. Okay, dot plots. You guys have seen these before, I'm sure. It's just dots where all the data points were. Okay, this is dot plot of the Kentucky Derby winning times. This is done vertically. You'll see that sometimes. I think more often you'll see them horizontally, where basically it would just look like this, just with all the dots for all the data points. Okay. All right, so as it's on, think before you draw. So make sure, first off, anytime we're working with our data, if we're going to make stem and leaf, histogram, dot plot, etc., make sure our variable is quantitative. Okay, don't try to make a histogram for a categorical variable. Right? It doesn't make sense to do that. So this is probably the most important slide on here, honestly. When describing a distribution, make sure to always tell about, actually I should say 4 things, but shape, unusual features, center, and spread. All right, so a little quick acronym for that. If that helps, sucks. Stats does not suck, by the way. Notice it's SUCS. So shape, unusual features, center, and spread. Those are the things you want to talk about anytime you're asked to describe a distribution. And you'll be asked that often. I can guarantee on the AP exam there will be some data and it'll say describe the distribution. Okay, so these are the things that we're going to talk about every time. All right, so make sure you write that down. It's super important there. And we're going to talk about how to do that. So shape. Basically, we want to look first. Does it have, how many modes does it have, or humps does it have in the graph? Okay, which you can see that in a histogram pretty well. Also want to look at, is it symmetric or is it skewed one way or not, which we'll talk about. And then with the unusual features, we'll look at some things that can happen there. So these humps or modes, all right, when you hear about the mode, that's like what occurs the most. So it's like in little parts of the histogram, what occurs the most. That's where those high parts of the histogram are. So if it has one main peak, we call that unimodal. All right. If it has 2 peaks, we call it bimodal. And then 3 or more would be multimodal. These are really rare. Okay. So generally, they're going to be unimodal, occasionally bimodal. Usually, if they're bimodal, that kind of tells us there might be like two groups in our data that maybe we should have separated. This is an example of histogram with bimodal. You can see there's 2 clear separate peaks there. Right? Sometimes you might not have any modes. It all kind of looks the same. We call that uniform. Okay, example would be flipping or rolling a die. If it's 6-sided and it's a fair die, you would expect same number of 1s as 2s, as 3s, as 4s, so it should be pretty well uniform. Okay, so it would be pretty much straight across. Okay, symmetry. All right, is it symmetric? And when we say symmetric, it doesn't have to be perfectly symmetric. Okay, if we look at this one, we would call this roughly symmetric. Even though you can tell it's not perfect. Okay, it's real life data. It's never going to be perfect. But if we kind of fold it over itself and it's fairly even, as you can see here, we call this, basically we would just say it's fairly symmetric. All right. Again, not going to be perfect, but it's in there. It's relatively symmetric. It's not perfect, but it's good enough for us. All right. Sometimes it'll be we say it's skewed one direction. So basically, when we say skewed, we're saying one tail is longer than the other. So you can look here. It's kind of a longer tail to this side. This one has a longer tail this way. Wherever the longer tail is, that's where we say it's skewed. All right, so if you have a long tail to the left, we say skewed left. Over here, the long tail to the right, we say skewed right. Right, unusual features. So things like outliers, that's the most common unusual feature. Or if there's any gaps in the distribution, sometimes that can tell us some good information. Those two things, mainly outliers and gaps, those are the main unusual features that we'll see. Right? I think most of you know what an outlier is. We'll talk about how to decide if it's an outlier later on. Right, there's an outlier. Okay, it definitely looks like an outlier. That one in our data that I showed on the calculator, wasn't as far away, so it may be harder to tell if that's an outlier or not. So sometimes it's easy to tell, sometimes not so easy. Okay, center of a distribution. And by the way, with outliers, we're going to talk in more detail down the road about that. How to truly tell is a pretty simple calculation to tell if it's an outlier or not. But now we're talking about center. All right, so one single number, if I wanted to describe all the data, what would we use? Okay, generally we talk about the center for that. If it's a perfectly symmetric histogram, center is easy to find. It's the one that's number right in the middle. Obviously real life data, it's not always like that. Sometimes it's skewed or has more than one mode, and it's a little more tricky. So first talking about the median here. Okay, so median is our middle value. You've probably heard of this before, I would hope. It says even number on both sides. If you have the same on both sides, like if it's have an even number of data points, then we average the two middle points to get the median. Basically just divides it 50-50. Okay, 50% above, 50% below. Okay, so we'll talk a little bit about, when we talk about center, we'll talk a little bit more about that besides median. We'll talk about mean also is another. We'll talk about that here in a little bit. Okay, when we talk about spread, all right, that's, statistics is about variation. That's what statistics is. And we'll talk about, there's different measures of spread that we use. How close are the values together? How spread out are they? We use a few different things. First one you've heard of, I'm sure, is the range. It's just our high value minus our low value, and whatever that number is the range. Problem with range is it's, if you have an extreme value, you have an outlier, it kind of messes everything up. It doesn't give us a true representative value. So range we don't use a ton, but obviously it is an option. The interquartile range is a little better. It kind of ignores those outside extreme values and focuses on the middle of the data and how spread out the middle of the data is. Okay, so notice it's called interquartile range. So we're going to first talk about, if we want to find that, what are the quartiles? So quartiles, basically quarters divided into 4 equal sections. So the 1/4 of the data is below what we call Q1, quartile 1. Another quarter of the data is above quartile 3. All right. And then, so it's a quarter below that, a quarter above that. So in between there would be 2 quarters, right? 50%. That's our interquartile range. And I'll show you a visual of that. But basically the Q1 and Q3, those are the borders of our interquartile range. So interquartile range is, this is Q3 minus Q1. Okay. There is a Q2 technically, but if you think about what is Q2, well, that would be whatever divides it. There'd be the next quarter, which would be 50th percentile, if you think about it that way, which is just our median. So Q2 is basically our median. We just don't call it Q2. Okay, here's a visual of the interquartile range with that earthquake data. Okay, you can see our 25th percentile, quartile 1, 75th percentile is quartile 3. Okay, this yellow area here is our interquartile range. It's our middle 50%. Very important to know how that goes together. Okay, so let me know if you have questions on that part. Okay, 5-number summary kind of puts your median, your quartiles, your minimum, maximum all together. We call it a 5-number summary. It's very important. Tells us a lot of information. And I can guarantee you there will be a multiple choice question in the AP exam involving a 5-number summary. And something like, so may just tell you what percentage of the values are above 7.6. Well, I can look here, quartile 3, right? It goes, this is my first 25%, second 25%, third 25%, fourth 25%. So 25% are above Q3, 75% below. Okay. So just think of it as breaking it up into our quarters. And as what I mentioned, you'll probably see a 5-number summary somewhere and then have to answer some questions about it. Right? We don't usually have to calculate that by hand. Right? Calculating the quartile is not really done by hand. We use a calculator for it or some sort of software. You'll be given it on the AP exam usually. Okay, box plot. All right, it's another method of displaying quantitative data. It's basically just a graphical display of your 5-number summary. So it's putting these numbers on a graph essentially. Okay, one thing they're really good if we're trying to compare two groups, box plots are really good for that. All right, they're also really good for outliers. So how we do this? Here's the start. All right, basically we just draw horizontal lines at and this could be done horizontally as well. We draw horizontal lines here. So this is my quartile 1. This one in the middle is my median. This one up here is quartile 3. Okay, we start with that and then we just make a box around it. All right, there's my box of my box plot. So again, Q1, median, Q3. Okay, then we do is we draw what are called fences. All right, we'll get into more detail about what these fences are. Basically, they're like cutoffs for outliers. So to find this upper fence, we take our quartile 3, whatever that number is, okay, and we just go, we find out, we've already found our IQR. We do 1.5 IQR, so say our IQR is 2. So we go 1.5 times 2, and that's how far away this upper fence would be. Okay. And then the lower fence is 1.5 IQRs below Q1. Okay, so below Q1, we go that far. Above Q3, we go that far. All right. So once we've got our fences, and we don't usually include the fences in our final box plot, just because it makes it kind of jumbled up. But once I've got my fences, I take the lines, I find the highest data point that's still below this number, whatever this highest fence was. So like 8.7 or something was maybe my highest earthquake magnitude here. That's still below that fence. So we just draw out to that point, and there's the end of my box and sometimes called a box and whisker plot. And they do the same thing this way. You go, however low our lowest value is, it's still within the fence, and that's where we end the box and whisker plot. Okay. Any values that are outside the fences, those are outliers, and then you just draw little dots for those. Okay. As you can see there were some outliers all over the place. All right. Notice those outliers didn't really show up back in that histogram. So something to think about. This is one thing that box plots do well, is show outliers. And as you can see, those look like outliers, but we probably wouldn't have guessed that these were also outliers. Same thing over here. So that's why it's important to make sure we know how to do multiple different types of graphs. All right. Really quickly, I'll show you here, making a box plot. Okay, so we've already got my data still. I hit second y equals. I'm already there, I guess. And then I just want to change this to the box plot that has the little outliers. Highlight that. Zoom 9. Okay, and you can see we do have an outlier there. All right, and there's my box plot. If I hit trace, there's my minimum. There's my Q1, median, Q3. Okay, and then this is my max that's not an outlier. Okay, notice it doesn't call it the max. All right, and then there's my max, that outlier at 19. So back to this. All right, so the mean. Okay, finding the mean. You guys have done this before. This is technically the formula for mean. All right, this is the Greek letter sigma, which means sum. All right, so if like y is representing a data point, or all the data points, so this means the sum of all the y's, so all of my data points divided by n is how many there are. All right, so add them all up, divide by how many there were. Very simple. You guys know how to do that. All right, this you probably have not seen. If I want to represent mean, you just put a mean of a data set, you just put a little bar above it. Okay, we call this technically, statisticians are very original. We call this y bar, because there's a bar above it. That's a mean, or it might be x bar. All right. Mean is basically our balance point of our histogram. So if it's skewed one way, it's going to kind of be brought that way. So it's always think about mean as your balance point. If you do that, it kind of makes it easier to estimate where the mean is. It's where a histogram balances if it was on like a scale. All right, mean or median, deciding which one to use. So median isn't affected by big values. All right, so like say I'm having the average height of people in our class, and we have a transfer that moves in that's 6'10". Right, that's going to really increase our average height of our class, right? Okay, that's not going to change our median a whole lot. Our middle value, or maybe it might bump up a little bit, but it's not going to change it nearly as much as our mean would change. All right, so median we say is resistant to extreme values. That's something else you'll see throughout the year. So if I'm trying to choose, when we talk about our center, we want to basically, you can either use your mean or your median. So with that, with the mean and median, sorry about my dog barking at the UPS man. Fun times in the Gratz household right now. But with the mean and median, we look at our data, we look and see if it's symmetric, no outliers, just use the mean. That's going to be our best bet. Okay, if we have a nice symmetric histogram, use the mean. If it's skewed or we have outliers, our mean is going to be affected quite a bit, and it's not going to give us a good measure of center. So in that case, when we have skewness or outliers, we want to use median. All right, so very important slide here as well. All right, so spread. Okay, we're not going to get into super deep detail with standard deviation today, or in this chapter, but I want to kind of show you so we need to know what it is though. So more powerful measure of spread than the IQR is called our standard deviation. Basically what it does is it tells us how far each data value is from the mean. All right, or listen to this carefully. On average, how far each value is from the mean. That's what the standard deviation tells us. Okay, so deviation means distance that a value is from the mean. So you have some above, some below. We can't just add all those together because they have positives and negatives, and they all cancel each other out. Okay, so we can't do that. So what we'd find is what's called the standard deviation. And it starts with this little formula here, which is called the variance, okay, which is our standard deviation squared. So what that is basically where we sum up all of our, what are called, squared deviations from the mean, okay, which if we look at this, what this is doing, so this is my data value. So say, look at my data set, I have like a value of 9. One of my data points is 9, I don't know, let's say 9 years old, let's say 8 years old or something. Minus our mean, whatever our mean is, okay? And then I square that value. And then I do that for every single data point. Okay, as you can see, you're probably not going to be, that would be very time consuming by hand. We don't usually do it by hand. But it's really important to know where the calculation comes from so you can analyze it better. So it's all of our differences from our mean squared. We add them all up and we divide it by how many there were, but not quite how many there were, divided by n minus 1. Right? There's kind of some complicated math and reasoning why that is. If you want to look that up, feel free. But you don't really need to know why. So this is our variance formula, which is standard deviation squared, which the reason we don't really use this right now, if I'm talking about analyzing the spread, is it's measured in squared units. Right, your book's really excited about that. But so we want to have it in the actual units of the measured units that we're actually talking about. So we use standard deviation, which is just a square root of that formula. Okay. So anyway, that's standard deviation. We'll talk more about that down the road. All right, so we talk about variation is kind of the key to statistics. It really helps us talk about what we don't know. Is the data tightly clustered around the center? Is it spread out or whatever? So if it's tightly clustered around the center, you're going to have a small standard deviation, a small IQR. Right? If it's way far out, then those numbers are going to be bigger. Okay, and all that those numbers kind of depend on your data. So you can't say like a standard deviation of 5 is large or small without looking at the data. So, okay, so again, make a picture. All right, that's the first thing we always want to do. All right, when we want to talk about our shape, our center, our spread, if there's unusual features, we want to make sure we mention them. If there's not, you don't have to mention it. Okay, but so shape, center, spread, with the unusual features thrown in if there are any. Remember, for shape, we talk about skewed. Okay, if it's skewed, we want to use median. We also use IQR. All right, if it's symmetric, we use mean and standard deviation. You could use median and IQR, but generally, if it's symmetric, stick with mean and standard deviation. If it's skewed, median and IQR. Same thing if there's outliers, median and IQR, because those aren't as affected. Okay, standard deviation is greatly affected by outliers, which again is something we'll look at later on. Okay, again, unusual features. There's multiple modes. Think about why. Okay, there are two different groups here in the data. We have, say, if I'm at a Little League baseball game and I'm analyzing the age of people there. Okay, you're probably going to have multiple modes. You'll have the young, good for the players. You'll have parents, and then you might have grandparents. You might have 3 modes. So then it might not be beneficial to analyze the entire group. We might want to split them up. Okay. If there's clear outliers, make sure. So if there are clear outliers and we need to report mean and standard deviation, which we will sometimes, we want to report what these are with the outliers, but also with them taken out. All right, so we can see, did they really affect it a lot? All right, again, that's why mean and IQR is usually what we use for if we have outliers. Okay, so just things to look out for. Make sure we don't try to make a histogram for categorical data. You can see there, we want bar charts, pie charts if it's categorical. Okay, don't try to say a bar chart is skewed right or something. Okay, bar charts aren't skewed because these are categories down here in a bar chart. Okay, so don't try to do this. This is bad. Okay, make sure with histograms we want to keep, they should be, if there's gaps here, that's a problem. Okay, because if there's a gap here that's showing there's nothing in this area. All right, so they should be together if they're done well. Like this is done well. There's obviously the gaps, meaning there's no values in there. Okay, so these should be together right here. All right, changing bin width. I'm going to show you in the calculator here real quick how to do that. You can mess around with it. It's kind of like finding, it's like kind of a Goldilocks rule. Too many bin or too small of a bin, too large of a bin. I'm going to find where is that kind of happy median there. Okay, so this stuff you can obviously read here. One thing to note, so don't report too many decimals. In stats, there's not a set number of decimals you need to do. Generally, 2, 3, 4 is fine. Don't report 50. And this one, don't round in the middle of a calculation. Okay, so just make sure, leave it in the calculator, continue working, and then round at the very, very end. And like I said, I'm going to show you here. You can obviously read this to yourselves. I'm going to show you how to make or change your bin width real quick, and that'll be it. Okay, you can read make sure you read through all this stuff though. Okay, so in the calculator, if I've got a histogram, let me make that back as a histogram again. Zoom 9 it. Okay, if I go to window, okay, right now if I trace, okay, you can see that's my bin width. If I go to window, right there is my bin width, X scale. Okay. So I can make that a 3. So that's going to make those bins wider. So it'll be basically like 9, 10, 11 now as part of the bin. And I just hit graph. Okay. If I hit zoom 9 again, it's going to reset it back to 2. Okay. So you can see that doesn't look real good there. All right. Those are too wide. If I tried to make it 1, okay, let's, that's okay, but, probably a little bit wide. That's why the zoom 9 generally gives you a pretty good bin width. You can obviously play around to get something you think looks better, but anyway, so to change bin width if you need to, window, and it's the X scale. It's a scale of the X axis. All right, so that's it. Let me know what questions you have. Sorry for a extra long screencastify here, but that's all we've got for today. So thank you very much.